Hello, this is Certified Genius 926, and I'm here with my lovely guest, Kendall. Say hi, Kendall.
Hi.
And today we're going to be doing examples of the Pythagorean theorem, as well as examples of the trigonometry functions sine, cosine, and tangent. Same things as what we did yesterday. If you haven't seen that, go like and subscribe to that video and this video. If you don't like and subscribe, you're not going to see this cute baby right here. So today, we're going to go over the Pythagorean theorem, sine, cosine, and tangent. First, we're going to start off with the Pythagorean theorem, which starts off with the formula known as a squared plus b squared equals c squared. Say that, Kendall. A squared plus b squared equals c squared. There you go. Alright, so if we go with the formula trying to solve for the hypotenuse of a right triangle, we're going to plug in our numbers for the formula. And since our formula is a squared plus b squared equals c squared, we're going to do... Kendall, you can't talk to the dog.
Yes, I am.
Not in the video. You gotta let him roam.
Okay.
But we're gonna have a squared plus b... Kendall, keep your eyes on the camera. Alright? And we're gonna have a squared... Kendall, keep your eyes on the camera. Okay. And we're gonna have a squared plus b squared equals c squared, right? So that means we're gonna plug in our values, which is 8 squared plus 7 squared equals c squared. 8 squared is 8 times 8, which is 64, right, Kendall?
Yeah.
And then we're going to have 7 squared, which is 7 times 7, which is 49, right? So that means our new thing is 64 plus 49 equals c squared. So if we plug this in a calculator, 64 plus 49, then that's going to give us an answer of 113. So 113 equals c squared. But we're not trying to solve for c squared. We're trying to solve for c, which is just the regular hypotenuse. So that means you're going to have to take the square root of c and the number of which you solve from 6 plus 49, which is 113, in order to get your answer. So the square root of 113, not of 100, the square root of 113.
Square root of 130 is approximately 11.402.
So the square root of 113 would be 10.63014588127. Or you could just keep it as c equals the square root of 113. That makes sense?
Yes.
So now we are going to do the next one. And the next one is a right triangle as always. And it's going...
The triangle's over there.
And it's going to be a regular triangle as always, the second one we're talking about. And the formula still stands. A squared plus b squared equals c squared. That means we're going to plug in our values. So 10 squared plus 8 squared equals c squared. That makes sense?
Yes.
So that means that that would be, what's 10 times 10, Kendall?
100.
It's 100. Good job.
100.
So that means that would be 100 plus 8 times 8, which is 64, which equals c squared. So we have to add 100 and 64 together in order to get c squared, right, Kendall? That means that 164 would equal c squared. And we have to take the square root because we don't want the hypotenuse squared. We want just the hypotenuse, right?
Yeah.
So we got to take the square root of 164 and the square root of 6 squared. A c squared. The square root of 164.
Square root of 160 is approximately 12.649.
Your answer will be 12.80624844749. Or, since that's incredibly irrational, right, Kendall? You could just keep it as c equals the square root of 164. But if a problem is asking you to give an exact measurement, you can just give them an exact measurement. Or you could just keep it as the square root of 164 if they don't want irrational numbers on the paper. You know what I mean? The teachers. They'd be crazy.
Yeah.
So, next we're going to do the next triangle, which is the last for the Pythagorean theorem. Example number 3. And we have some simple numbers, 2 and 5, for A and B. The formula still stands as a squared plus b squared equals c squared. What's the formula, Kendall?
Over.
It's over. It is over. Say it, Kendall. It is over.
It's over.
Yes, over. So the formula is a squared plus b squared equals c squared. So that means that 5 squared plus 2 squared equals c squared. And the reason you can just decide which side is A or B is because, the associative property adding, it really doesn't matter in the order of which you put them. So we know that 5 squared, which is 5 times 5, is what, Kendall?
Over.
25. It's 25. So that means that if we do 2 squared, which is 2 times 2, that would be plus 4, which equals c squared, right? So that means that 29 is equal to c squared. So that means that you would take the square root of c squared, 29, to get that c would either equal the square root of 29, or it could be an irrational number. Kendall,
Yeah.
you look like that girl from The Conjuring. Yeah, you scary.
No.
Yeah.
No, not.
So the square root of 29 is going to equal 5.385164807113. So, or you could just keep it as a square root of 29. As I said, we're just going off of the square root because it's a very irrational number. So now, going aside from the Pythagorean theorem, we're going to go to the sine, cosine, and tangent of angles of right triangles. As we went over yesterday, sine, cosine, and tangent are trigonometry functions, of which you can find of an angle being like the opposite of that angle over the adjacent side of that angle. Things of that nature. So that means that for the first one, because I really don't want you to get confused by all the numbers on the page, there's a little divider from the top and the bottom. You see this is the sine, cosine, and tangent. So for the first one, our opposite side, our triangle really, has the angle of 60 degrees, and our opposite of that angle is 2 times the square root of 3, and we have 7, I believe. Yeah, it's 7 for the adjacent side of that angle. So for number 1, the example number 1 of sine, cosine, and tangent, sine 60 degrees of this is going to equal the remember, we went over this thing yesterday. Say it, Kendall. SOHCAHTOA.
Toa.
And that basically means for the so part, which is spelled SOH, is that the sine equals the opposite side of that angle over the hypotenuse, which is the longest side of a right triangle.
Over.
You know, Kendall. Give me some fist. Give me some punch. So that means that that's going to equal the opposite of the angle, which we said is 2 times the square root of 3, over the hypotenuse, which is 9. And then cosine, which if we follow SOHCAHTOA, cosine equals... You know, why are you playing with my ear? Okay, well, cosine equals the adjacent side of the angle over the hypotenuse. So that means that the cosine of 60 degrees... Kendall, what are you doing?
I heard this.
You see, she just has a regular old pencil in her hand for no reason. Okay, so that means that this is going to equal the adjacent side with my face. Is going to equal the adjacent side of the triangle being 7 over the hypotenuse, which is 9. So now we're going to go to tangent of 60 degrees. And tangent is very odd because it doesn't use the hypotenuse at all. Because TOA, which is spelled T-O-A, means that the tangent equals the opposite of the angle over the adjacent side, which is 7. That means that the tangent of 60 degrees is going to equal this 2 times the square root of 3 over 7. Now, I know that seems like a long process, but when you start doing trigonometry, you'll kind of get it, so you know what I mean? Would you like to say anything to the camera, guest star?
Yeah.
What would you like to say?
I say, ah!
Are you trying to sing Frozen 2?
Yeah.
You love Frozen 2, huh? Alright, so now we're going to go to example 2.
I will do it too.
You want to do example 2 too?
Yeah.
Okay. So example 2 is right here. We see that the angle is 30 degrees at the bottom now. So that completely changes our whole perspective of the opposite and the adjacent side of the angle. Isn't that right, Kendall?
Yeah.
So that means that
Thank you, Chloe.
the sine of the 30 degrees is going to equal the opposite over the hypotenuse. Make sense?
Yeah.
So that means that the opposite of the 30 degrees in this case would be 7, and the adjacent side would be 6. The adjacent side of the triangle would be 6, and the hypotenuse is 10, if you saw it in the picture. So that means that our sine is going to equal the opposite over the hypotenuse. That's going to mean that it equals 7 over 10. And then our cosine of 30 degrees is going to equal our adjacent side over the hypotenuse, which means that it's going to equal 6 over 10. Make sense, Kendall?
Yeah.
You like math, huh?
Yeah, I like math. Let's go do it together.
And that means that our tangent, which is the opposite over the adjacent side, is going to equal 7. Well, tangent of 30 degrees is going to equal 7 over 6.
Over 18. And over the 8.
Hey, Kendall. How you doing with the math?
Good.
You want the people to see your math?
Yeah.
Her math is at the bottom, people. It's very, very, very nice, huh, Kendall?
Yeah.
If you want to see more of Kendall's math, make sure and you do not forget to like and subscribe to this video. And next, we're going to do the final sine, cosine, and tangent problem, which is number 3. And for the right triangle, it's the final one on this page. It's this one. I'll flip the page. Only because, there's a lot on that side. So, I understand if you're, really confused. So, sine, well, let me give you a new triangle.
Over the sine.
Let's say this is 10, This is 2, and then the hypotenuse could be 20. I don't really care.
No.
So, Kendall, the pencil.
No, I have to draw too.
Here you go.
Thanks.
So the sine of the degrees, which we're gonna say is 50 degrees. Does that make sense? Is that awesome? Kendall.
What? They have a face.
What? Okay, so sine of the 50 degrees, which the 50 degrees, you see her math? You see her math? She's the future mathematician of NASA, people. That's art, people. Say that's art.
That's art, people.
Yeah. Alright, so this is our triangle. You see where the angle is? It's a 50-degree angle. And we know from the saying so-ka toa
Toa.
that sine of the 50 degrees is the opposite over the hypotenuse. So the opposite of the 50 degrees in this case is 10 over the hypotenuse, which is 20. Cosine of this, say cosine.
Cosine.
There you go.
Cosine Toa.
The cosine of the 50 degrees would be the adjacent side, which is 2, over the hypotenuse, which is 20. And now we're going to do tangent of the 50 degrees. The 50 degrees. This is the second time you done ruined one of my videos. Because you done made me look at you. Just go.
I told you to look back.
Also, let's give a shout out to AJ. Yes, you do. AJ0001. Fortnite name KillerFaze5280. He is a part of the FaZe clan.
No.
What clan are you a part of?
BC.
He is a part of DC or BC?
BC.
He is a part of the BC clan, and he is a very awesome dude at Fortnite. So, just giving him a shout out. Now, since he just ruined our video, we can finally get back to tan of 50 degrees. Did he ruin our video, Kendall? He did. He ruined it real quick.
Yeah, he ruined it.
So, tan of 50 degrees, following the saying so-ka toa, tan is equal to the opposite of 50 degrees, which is 10, over the adjacent side of the angle, which is 2. Which you can also reduce to like 5, you know, because like you can simplify all the time if you want to. It's very optional. It depends on what the directions on a math paper or problem or exam or something says. So that is the end of this trigonometry examples video.
No.
Make sure you it's not the end, Kendall.
No.
Right before we end, we're gonna see Kendall's masterpiece. It's a beautiful math, huh?
Yeah, it's beautiful.
Are you gonna be a mathematician when you get older?
Yeah.
Alright, so that's the end of our video.
No, not.
For today. Like and subscribe to this video if you want to see more.
No.
Kendall. Yes.
No, not.
Say deuces.
No.
Yes, say deuces. That's our outro.
No, not the end.
Yes.
No,
You have
not.
to say deuces.
No,
Yes.
I can't.
Yes, you can. Put up the peace signs. Say deuces. Say it, Kendall. You gotta say it. Deuces.
Do time.